A better tomorrow. A tomorrow needs sustainable technologies. Tomorrow needs green pioneers. R&D Center for Reduction of Non-CO2 Greenhouse Gases. We make a better tomorrow. The Earth we are living in is a home to 7.4 billion people, 300,000 kinds of plants, and 1.5 million of animals. It is a place that we should preserve for our children and future generations. Now, the Earth, however, is suffering from unusual weather and global warming. Because the cause of this problem is attributed to the greenhouse gases, the United Nations manages to solve the problem. Generally, methane, nitrous oxide, and fluorinated gas are referred to as non-CO2 greenhouse gases. The non-CO2 reduction will be achieved easing by development a cost-effective unit technology. To develop non-CO2 reduction technology, Korea launched R&D Center for Reduction of Non-CO2 Greenhouse Gases in September 2013. We are developing the optimal reduction technology for each type of gases and sources. The main causes of greenhouse gases. Methane. Methane emitted in the atmosphere is increasing every year, and it is the second highest global warming gas next to carbon dioxide. With 12 years lifetime in the atmosphere, about 60% of anthropogenic methane is emitting from natural gas, rice farming, and landfill. It is also known that the greenhouse effect is about 20 times higher than that of carbon dioxide. Methane, one of the main components of natural gas, is a useful energy source that could be used. It is right time to develop its recovery technology. Our center is conducting research on the energy utilization as well as the mitigation of methane. Movable methane purification plant, including membrane technology, for the application of anaerobic food waste treatment site. Technology of demonstrating for methane recovery and nitrous oxide treatment from anaerobic digestion gas of livestock manure. Direct conversion technology of methane from landfill gas by dry reforming process. LFG upgrading to methane fuel and conversion of hydrogen sulfide impurity to high-value added biosulfur. The results will be used as novel methods for reduction of methane, one of the greenhouse gas. Development of movable methane purification plant, including membrane technology for the application of anaerobic food waste treatment site. The country generates about 15,000 tons of food waste per day, accounting for about 26% of domestic waste. Our technology is to purify biomethane out of increasing food waste and make it available as renewable fuel. This technology process consists of pre-treatment of wet processing and multi-stage membrane separation process. First, equipment to collect digestive gas is installed at the existing food waste treatment site to generate biogas. The biogas generated is pre-treated to remove foreign substance, such as moisture, hydrogen sulfide, siloxane, and ammonia. And then the carbon dioxide is separated through high purification technology, using membranes, and pure methane gas is left. The newly developed membrane purification technology can reduce the size of a plant to 1/3 compared to existing purification technology, and has many advantages that do not require expensive catalyst and wastewater treatment. Our methane purification membrane separation plants and original membrane technology using pre-treatment desulfurization technology takes on a pioneering role in greenhouse gas reduction, as well as high-purity methane business. Development of the technology of demonstrating for methane recovery and nitrous oxide treatment from anaerobic digestion gas of livestock manure. Methane with 21 times stronger greenhouse effect than carbon. Technology to reduce greenhouse gas and secure renewable fuel, being biogas as a valuable energy resource. Our technology is an eco-friendly solution that can purify methane into a high degree of fuel and treat nitrous oxide from biogas discharged from livestock manure by utilizing membrane contractor process as a source technology. The membrane contractor is a process that allows both mixed gas and absorbent liquid to come into direct contact with each other, and then makes a specific gas with high solubility selectively absorbed into the absorbent to separate the mixed gas. In addition, the high-efficient integrated separation and purification technology has advantages such as easy installation, small installation space compared to other rival processes, and low installation and operating expenses. Furthermore, the system is very simple in process as well as easy in scale-up. This system goes through sequentially the following processes: pre-treatment of biogas, absorption of gas in membrane contactor, desorption of the absorbed gas in membrane contactor, and deodorization and greenhouse gas removal processes. The pre-treatment process removes moisture, mist, and dust from the biogas, and the absorption membrane contactor process purifies methane through the absorption of carbon dioxide and hydrogen sulfide into the absorbent liquid from the pre-treated biogas in membrane contactor module. This technology maximizes the performance of separation technology by optimizing the structure of the membrane module and uses pure water as absorbent so that it can solve problems such as wetting phenomenon of membranes, corrosion of pipes and vessels, and large energy consumption of regeneration of corrosive organic amine absorbent of the existing membrane contactor process. It also increases the separation efficiency through increasing the absorption of carbon dioxide and hydrogen sulfide by increasing process pressure. The absorbent water is regenerated and recycled in the process through desorption of carbon dioxide and hydrogen sulfide from the water by applying vacuum to the water phase in degassing membrane module. The desorbed hydrogen sulfide will be removed by absorption and deodorization process so that the protection of the air environment would be achieved. Our technology leads: being biogas as a valuable energy resource, preemption of the technological superiority on the membrane contactor process, and solutions to greenhouse gas problems such as methane and nitrous oxide. In addition, we can utilize the developed technology in other fields, including natural gas purification, production of ultra-pure water for semiconductors, and desorption process of power generation water and food industry water, which have a big ripple effect. Direct conversion technology of methane from landfill gas by dry reforming process. Efficient operation and management of landfill gas recycling facility that matches Korea's circumstances and a solution that can be utilized in small to medium scale landfill sites. Landfill methane direct conversion technology. The main process for collecting landfill gas and ultimately utilizing it is as follows. Gas collection system consisting of landfill gas collecting line, transfer pipe and transfer pump, pre-treatment process to remove impurities in gas, and direct conversion technology that utilizes this. The pre-treatment process for removing the impurities in the landfill gas is composed as follows. Buffer tank, inertial impact type heat exchange and dust collector, which simultaneously removes fine dust and moisture, and an absorption device that simultaneously removes hydrogen sulfide and silazane. Landfill gas from which impurities have been removed through a pretreatment process directly reforms methane and carbon dioxide via a reforming reactor to produce hydrogen and carbon monoxide. Furthermore, it can produce DME fuel through the DME catalytic reaction process and can separate high-purity hydrogen by separating and purifying hydrogen in the reformed gas. Also, the landfill gas that has undergone the pretreatment process is used as re-energy by producing electricity when the fuel running the gas engine is produced. Our technology will be an important means of energy independence by producing energy equivalent to 313,000 barrels of annual waste in the Korea-type landfill gas recycling facility to reduce greenhouse gas emissions. It is friendly energy technology. In addition, from the economic aspect, we can create an economic effect that will reach $58 million annually, including an alternative energy effect of $33 million and carbon credits of $24 million. Landfill gas upgrading to methane fuel and conversion of hydrogen sulfide impurity to high-value added biosulfur. Various types of garbage, such as food wastes and construction wastes, are buried in landfill. As they are decomposed, methane, carbon dioxide, hydrogen sulfide, and silazane are generated. Methane is a greenhouse gas that shows 21 times stronger greenhouse effect than carbon dioxide, but it can be used as useful fuel when it is separated from the landfill gas. Hydrogen sulfide is a toxic pollutant which must be removed. Our new technology consists of a series of processes to remove carbon dioxide and impurities such as hydrogen sulfide, silazane, and ammonia from the landfill gas to separate methane gas with 70% purity and to utilize this methane as a fuel to dry sewage sludge. Recently, as the amount of construction waste increases, the concentration of hydrogen sulfide in the landfill gas increases to 2%. It is urgent to develop the technology to remove a large amount of the hydrogen sulfide at low cost. In our technology, hydrogen sulfide is collected by an absorption method using aqueous sodium hydroxide solution and is converted to high-value added biosulfur by using bacteria in the bioreactor. Biosulfur can be used as a raw material for cosmetics, a soil conditioner, and an eco-friendly disinfectant which kills various harmful fungi for vegetables, fruits, and ginseng. After the removal of the hydrogen sulfide, the landfill gas still contains impurities such as silazane and ammonia. As these chemicals degrade the performance of a heat exchanger, a burner, engine, etc., during the combustion of landfill gas by deposition of polymeric silicon oxides, they must be removed. Our technology uses a new developed absorbent, which can be recycled in order to remove silazane with low concentration, less than 13 ppm, and to completely remove ammonia. Outgas, which hydrogen sulfide, silazane, and ammonia are removed from the prior process, consists of methane, carbon dioxide, and air. The water absorption process, based on the dissolution of carbon dioxide in water, is used to remove carbon dioxide, and to produce heavy gas with 70% methane purity. Our technology is energy-reducing and cost-saving method, which uses methane obtained from landfill gas as a fuel to dry sewage sludge instead of expensive liquefied natural gas. Furthermore, by using this technology, we can reduce emission of methane, which is powerful greenhouse gas emitted from the landfill gas. Nitrous oxide is commonly known as laughing gas because inhaling it causes laughing human face by the effects of anesthesia. It accounts for about 6% of anthropogenic greenhouse gas, as shown in the results of various investigations. Nitrous oxide is generated in the atmosphere by the Earth's nitrogen cycle and several natural elements. The concentration, however, increases every year due to the artificial factors, such as agriculture, combustion of fossil fuel, wastewater treatment, and industrial activities. The lifetime of nitrous oxide in the atmosphere is about 120 years, and its global warming potential is 310. The abatement techniques of nitrous oxide include pyrolysis, catalytic decomposition, and electrochemical method. To reduce nitrous oxide, our center has developed remarkable solutions with the following research fields: fluidized bed materials and fluidized bed combustion processes to suppress nitrous oxide emissions, catalyst and combined treatment process for reduction of high-low nitrous oxide concentration, diesel after-treatment system to minimize nitrous oxide formation, technology for the recovery and purification of high-purity nitrous oxide from industrial emission gases. Development of fluidized bed materials and fluidized bed combustion processes to suppress nitrous oxide emissions. Even though nitrous oxide is one of main greenhouse gases, conventional sewage sludge incineration systems do not include nitrous oxide abatement technology and thus have released a large amount of nitrous oxide. We have developed a new incineration system, suppressing nitrous oxide emission as well as fluidized bed materials as a catalyst to decompose nitrous oxide at high temperatures in an incinerator. Sewage sludge fed into the system is incinerated by heating up with the fluidized bed material and mixing with the combustion air. Unburned gas generated in the fluidized bed is completely incinerated in the freeboard. While the conventional systems utilize sand as a fluidized bed material, our system uses a specially designed catalyst to remove nitrous oxide and reduces nitrous oxide emissions. Moreover, special nozzles installed on the air distribution plate can improve the mixing efficiency of the dried sewage sludge and prevent local overheating. The newly developed catalyst with high mechanical strength consists of highly active components in nitrous oxide abatement. When ash of the sewage sludge is discharged from the bottom of the fluidized bed incinerator, a catalyst separation device recovers the catalyst for reusing. In addition, the enhancement of combustion performance can be achieved by increasing the mixing rate of combustion gas with the secondary air injection at high speed. The incorporation of the developed fluidized bed incinerator into a sewage sludge drying system enables stable treatment of sewage sludge at low cost. The developed incineration technology, using a highly efficient nitrous oxide decomposition catalyst as a fluidized bed material, can reduce nitrous oxide in the incinerator without an additional installation of a post-treatment facility. Furthermore, high decomposition temperatures can minimize the deactivation of the catalyst in the presence of acid gas, such as sulfur oxide. The newly developed fluidized bed material and fluidized bed incineration system to suppress nitrous oxide emissions accomplishes 90% of nitrous oxide reduction and 85% of catalyst recovery. Development of catalyst and combined treatment process for reduction of high-low nitrous oxide concentration. Nitrous oxide is not harmful to human body, but shows 310 times higher global warming index than carbon dioxide. The main sources of nitrous oxide emissions in industrial processes are a chemical process emitting high concentration nitrous oxide, a combustion process emitting low concentration nitrous oxide, and semiconductor and display processes. Recently, nitrous oxide emissions have been increasing day by day due to industrial development. The emission characteristics of nitrous oxide vary widely according to each industrial process, and nitrous oxide is generally emitted together with nitrogen oxide. Our technology is the process to treat nitrous oxide using catalyst technologies and has the advantage to reduce nitrogen oxide together. Based on these core technologies, we are able to provide the optimum abatement process suitable for the emission characteristics of various industrial processes. Unlike conventional processes to reduce nitrogen oxide and nitrous oxide in two phases, our technology, which is applied to the chemical processes where nitrous oxide is discharged at high concentration, minimizes facilities as it can simultaneously process the two phases in a single reactor, using a single catalyst and a reducing agent. In particular, compared to conventional catalysts operating at high temperatures, the operating temperatures have been closely reduced to the nitrogen oxide reduction temperatures, which can greatly contribute to energy saving. Based on the current basic research, we have developed a chemical processing commercial plant with a capacity of 1,000 normal meters cubed per hour. We have achieved excellent nitrous oxide and nitrogen oxide removal performance of 95% or above through demonstration operation of nitric acid production process. The combustion process has larger exhaust gas flow rates than other processes and contains a large amount of catalyst poisons. We have developed a honeycomb-type catalyst suitable for the characteristics of combustion exhaust gas and have enhanced the durability of catalysts against poisonous substances. As exhaust gas emitted from the electronics industry contains dust and acid gas, it is very difficult to apply nitrous oxide abatement technology. The nitrous oxide abatement process for the electronic industry consists of a pre-treatment process and a catalyst reduction process. Dust and acid gas are removed in the pre-treatment process. Nitrous oxide decomposition catalysts, considering the characteristic of fluctuating concentrations of nitrous oxide, boast more than 80% removal efficiency at 350 degrees Celsius or less. Nitrous oxide nitrogen oxide abatement process that shows superior performance over advanced technologies has reached commercialization to visualize business. Our technology can replace nitrous oxide technology, which is dominated by developed countries with pure domestic technologies, and make national interests by expanding its business into overseas markets. In addition, the technology can greatly contribute to reduction of domestic greenhouse gas emissions, as it is possible to preempt the nitrous oxide market by securing an original technology in the unexplored fields, such as the combustion process and the electronic industry. Development of diesel after-treatment system to minimize nitrous oxide formation. considering nitrous oxide abatement technology to cope with nitrogen oxides regulation of construction machinery and agricultural machinery, except automobile, a leading technology of new concept exhaust gas treatment. Our technology meets the off-road emission regulations that have been in force since 2015. The microporous titanium dioxide modified by hydrothermal synthesis and the zeolite catalyst prepared by controlling the ion exchange ratio and mixing the specific ratio are applied to suppress nitrous oxide generated in the exhaust gas treatment without additional equipment. We have developed the microporous titanium dioxide with high ammonia SCR stability and nitrogen selectivity at high temperatures and applied it to meet the off-road Tier 4 regulations. And we have reduced nitrous oxide emissions by 1/3 compared to after-treatment equipment. We have developed a reaction model to convert urea to ammonia according to the mixer and vane shape. We have designed and developed the urea dosing control unit by engine load and the after-treatment applications. The newly developed nitrous oxide abatement technology satisfies Tier 4 regulations and effectively suppresses nitrous oxide produced in after-treatment system. Development of technology for the recovery and purification of high-purity nitrous oxide from industrial emission gases. This technology of recovering high-purity nitrous oxide can reduce the emission of nitrous oxide, which is a non-CO2 greenhouse gas, and abate global greenhouse effect by recovering high-purity nitrous oxide of 99.999% from emission gases of adipic acid or nitrous oxide manufacturing processes, which contain 30 to 50% of nitrous oxide. High-purity nitrous oxide, recovered, can be used for semiconductor and LCD manufacturing processes as an oxidizing agent and for medical anesthetic. The high-purity nitrous oxide manufacturing process under development in this research consists of pre-treatment process to remove dust and carbon dioxide contained in emission gases, membrane separation process to concentrate emission gases containing 30 to 50% of nitrous oxide into about 90%, and low temperature and high pressure distillation process to recover high purity nitrous oxide of 99.999% from the gas mixture concentrated by membrane separation process. The technology of recovering high-purity nitrous oxide is not commercialized yet worldwide, and we are developing the technology for the first time in the world. This is the detailed design, drawing of the low-temperature and high-pressure distillation process under construction in the first year of this research. The construction of the low-temperature and high-pressure distillation process to recover high-purity nitrous oxide of 99.999% from the gas mixture containing nitrous oxide of about 90% is currently underway. We have a plan to complete the construction of the pilot plant for recovering nitrous oxide, including the pretreatment and membrane separation processes, by the second year of this research, and to develop the optimized purification process technology through the operation of the pilot plant in the third year. The recovery process of high-purity nitrous oxide, which we are developing in this research, can generate emission gases containing nitrous oxide of about 1 to 5%. To prevent air pollution due to these emission gases, we are simultaneously developing a thermal decomposition technology of nitrous oxide with high-frequency induction heating. The thermal decomposition technology can reduce the concentration of nitrous oxide of the emission gas to less than 100 ppm by decomposing nitrous oxide. This thermal decomposition technology with high-frequency induction heating, which we are developing in this research, is the first one in the world, and we will be able to have international patents. By applying the technology developed in this research to domestic industrial emission gases, nitrous oxide of a non-CO2 greenhouse gas can be recovered and reused in the industry. Through this, we can reduce about 9 million tons carbon dioxide of greenhouse gas emission annually and expect the increase of annual sales of more than $17 million. In addition, we can lead the technologies of recovery and decomposition of nitrous oxide by developing both the process technology of high-purity nitrous oxide recovery and the thermal decomposition of nitrous oxide with high-frequency induction heating for the first time in the world. Fluorinated gas reduction technology, the main cause of long-lasting man-made greenhouse gas, F-gas. Unlike other greenhouse gases, F-gas has no natural sources and is generated from a variety of industrial fields, such as aluminum and semiconductor manufacturing factories. In addition, the gas remains in the atmosphere for several thousands of years, and it can be decomposed at high temperatures above 1,000 degrees Celsius. F-gas is one of the most powerful and long-lasting greenhouse gases produced by human beings. It can be mixed well and diffused simultaneously in the atmosphere. Since 2013, our center has proposed new strategies to significantly reduce F-gas through the following R&D. Pre-after treatment system for the non-CO2 gas abatement system by use of catalyst and high ionized energy. Integrated system for separation, purification, recovery, and reuse of fluorinated gas emitted from the electronic industry. Thermal destruction and pollutants control system for used hydrofluorocarbons. High-efficiency recovery and separation technology for discarded refrigerants recycling. High-performance abatement technology for pre-fluorinated compounds and nitrogen trifluoride with high destruction rate and energy efficiency. Pre-fluorinated compounds treatment and recycling system using reaction-enhanced RCS. Small-scale air cooling system using eco-friendly natural refrigerants. Greenhouse gas removal system by using combined pump and scrubber technology. Developing project of pre-after treatment system for the non-CO2 gas abatement system by use of catalyst and high ionized energy. Sulfur hexafluoride, which is generated in semiconductor and LCD processes, is a representative gas causing the greenhouse effect. Direct oxidation technology and plasma technology have been used to treat the gas, but reduction efficiency and high installation and operation costs have been problems. Our technology enables batch processing at the final exhaust and can be applied to the existing process. It can perfectly respond to the sulfur hexafluoride problem occurred in semiconductor and LCD process. The system applied automatic cleaning electric dust collection technology was applied to pre-treat hydrofluoric acid, dust, mist, etc., including sulfur hexafluoride in the environment of discharging complex pollutants of semiconductor and LCD processes. After capturing more than 95% of particulate matters, it was irradiated with an electron beam that generates high ionization energy to ensure sulfur hexafluoride treatment efficiency of 95% or more. To discharge some sulfur hexafluoride gas not treated in the atmosphere, catalyst treatment is grafted. SF6 gas activated in an electron beam can react at low temperatures compared to conventional catalyst treatments. In the result, technological advances have been made to dramatically improve performance and lifetime of a catalyst. Sulfur oxide and hydrofluoric acid generated after a decomposition process are treated by the simultaneous absorption system in the final step. The structure, considering the fluid velocity and the increase of a cross-sectional area for absorption performance, is reflected to build the stable final air management system. Our system is applicable to both existing plants and new plants that do not have greenhouse gas treatment facilities, leading to reduction of greenhouse gas emissions with high treatment efficiency and low installation and operation costs. Integrated system for separation, purification, recovery, and reuse of fluorinated gas emitted from the electronic industry. Many of greenhouse gases emitted in the electronic industry were not controllable. Our technology is a new pre-fluorinated compound gases separation system that can separate nitrogen and PFCs gases and reduce unnecessary energy loss from existing methods that require large amounts of energy to treat pre-fluorinated compounds in the exhaust gas. The water cyclone process, or a pre-treatment process, removes powder, moisture, and acid gas contained in the exhaust gas, compresses the exhaust gas by a gas compressor, and supplies it to the system to maintain stable system performance, even in the long-term operation. Our system separates the pre-fluorinated compounds gas through hollow fiber membrane connected in parallel. Nitrogen is discharged into the air, and concentrated pre-fluorinated compounds gas is reduced up to 50% inflow loads to the scrubber based on the recovery rate of 95%, through which we can expect low expenses and high efficiency, from increase of treatment efficiency to reduction of treatment expenses and greenhouse gases. Thermal destruction and pollutants control system for used hydrofluorocarbons. Thermal destruction technologies are applied to treatment of hydrofluorocarbons, a used refrigerant generated during disposal of various air conditioners and refrigerators. But expensive treatment cost and a large amount of fossil fuel are consumed. Our system has adopted a technology to improve the energy efficiency by breaking the highly stable refrigerant at high temperatures, and simultaneously to cool the inner wall of a combustion chamber with combustion air. The process of disposal of used refrigerants is to inject the used refrigerant after preheating them by using auxiliary fuel to decompose them into carbon dioxide, hydrogen fluoride, and water. Hydrogen fluoride, removed by reacting with the neutralizing agent, carbon dioxide and water, etc., are discharged through the stack. The wall of a combustion chamber is composed of a double structure, so that the combustion air flows in a fluid path between the outer wall and the inner wall, and rotates 180 degrees along the wall of the double structure. Combustion air, to help cool the inner wall of the combustion chamber, forms air curtain and prevents corrosion by acid gases. The combustion air that rotates along the inner wall will join strong turbulent flow formed in the center of the burner. The used refrigerants supplied to the burner is completely decomposed at the maximum temperatures of 1,200 degrees. In addition, some of the cooling air of a burner used at this time is replaced with recirculated exhaust gas discharged through the chimney to reduce nitrogen oxides and improve energy. The combustion technology for thermal destruction of waste refrigerant is excellent in energy efficiency and can prevent corrosion by preventing combustion gas contact. Our technology is a new system that effectively treats used refrigerants without discharging them into the atmosphere by recycling and destroying hydrofluorocarbon gases. High-efficiency recovery and separation technology for discarded refrigerants recycling. Hydrofluorocarbons, one of greenhouse gases, are used as refrigerants for household and industrial air conditioning equipment, but they are substances that increase global warming by illegally discharging into the atmosphere because of no recycling technology. Our technology is the first eco-friendly technology in the country that separates, purifies, and regenerates contaminated or mixed refrigerants with high purity. A refrigerant boils instantly at room temperature as it has a low boiling point. It has physical properties which each refrigerant has different boiling point. Our technology is to sequentially separate and purify contaminated refrigerants with high purity by using different boiling point of each refrigerant. When the contaminated or mixed refrigerant is recovered, heated, and vaporized, it flows into the bottom of the distillation tower. In this way, only the refrigerant with high boiling point is selectively condensed in the distillation tower and collected at a point at the bottom of the distillation tower. Then, moving to the top of the distillation tower in the gaseous state, it is condensed and separated and purified into a high-purity single refrigerant. In addition, IoT-based technology was developed to operate and control the 24-hour system at all times. Our technology has been recognized by the Ministry of Environment for its excellence and greenness, and we have obtained 4 patents related to the technology. As discarded refrigerants are separated and purified with high purity, it can get import substitution effect on refrigerant demand, which relies only on import. And the regeneration of refrigerants that have stopped to produce due to international treaties is a strategic eco-friendly technology which can respond to demand of the national key industry, defense and industries, and contribute to solving the global warming problem. Development of high-performance abatement technology for perfluorinated compounds and nitrogen trifluoride with high destruction rate and energy efficiency. This development is supported by the R&D Center for Reduction of Non-CO2 Greenhouse Gases, funded by Korea Ministry of Environment as Global Top Environment R&D Program. Perfluorinated compounds and nitrogen trifluoride as a non-CO2 greenhouse gases widely used in semiconductor or display industry, and they should be decomposed before being emitted to the ambient. Lower PFC's destruction rate and excessive energy consumption are most big issues for the conventional abatement system for perfluorinated compounds and nitrogen trifluoride destruction. In order to overcome those lower perfluorinated compounds destruction and excessive energy consumption users, we developed the new abatement system for perfluorinated compounds and nitrogen trifluoride. Our system can destruct the perfluorinated compounds up to 95%, with saving the energy over 30% compared to the conventional abatement system. Key technology is excess enthalpy combustion technology, which can realize the effective and energy-efficient destruction. The combination in porous medium is a sort of self-recuperative combustion. The waste gas, including pre-fluorinated compounds, mix with fuel and oxidizer, and then the pre-mixed combustion occurs in a porous medium, which has high thermal conductivity and radiation emissivity. So, the high-temperature heat generated from combustion is directly transferred to the waste gases, and this direct heat transfer to the waste gas and internal heat recirculation by porous medium can realize effective and energy-efficient pre-fluorinated compounds destruction. Another key technology to realize the effective and energy-efficient destruction is appropriate enrichment using pressure swing absorption technology. The main principle of PSA technology is to separate and exhaust the nitrogen selectively, up to 50% in the waste gases, and then it makes decrement the load of combustor. Dry particle collecting technology is also applied in front of PSA system. To remove hydrogen fluoride, which generated from the combustor by destruction of pre-fluorinated compounds and nitrogen trifluoride, the high-performance wet scrubber is also applied at the rear of combustor. We expect our development abatement system contributes to improve the atmospheric environment applying to the various industry. Development of pre-fluorinated compounds treatment and recycling system using reaction-enhanced RCS. About 10 to 50% of pre-fluorinated compounds used in semiconductor, liquid crystal, and solar cell manufacturing processes are discharged unreacted into the atmosphere. Our system is an economical processing system that can remain energy usage below 0.1 kilowatt-hour per normal cubic meter through low-temperature operation and waste heat recovery. Hydrogen fluoride generated during the decomposition of tetrafluoromethane is continuously removed by using solid phase reducing agents such as calcium oxide, calcium carbonate, etc. Innovative technology that can lower the reaction temperature and fundamentally block hydrogen fluoride efflux. These RCSs originally blocks hydrogen fluoride emitted from the RCS. To maximize energy efficiency by easy recovery of waste heat through a heat exchanger. To reduce catalyst durability by hydrofluoric acid. To maximize energy efficiency and improve catalyst durability by low-temperature operation. To compact process due to elimination of back-end hydrofluoride absorption process. To recover resources by production of calcium fluoride. Development of small-scale air cooling system using eco-friendly natural refrigerants. Hydrofluorocarbons, which are hydrofluorocarbon refrigerants with very high global warming potential, are mainly used for household and automotive air conditioners. As the global warming problem becomes more serious, there is a growing interest in using eco-friendly refrigerants with low global warming potential to replace such refrigerants. Carbon dioxide is one of eco-friendly natural refrigerants with a remarkably low global warming index. Carbon dioxide is safe, non-toxic, and earth-abundant natural refrigerant, which has been used for long decades before synthetic refrigerants, such as chlorofluorocarbons, hydrofluorocarbons, were commercialized. However, since the existing cooling technology using carbon dioxide as a refrigerant has an extremely high operating pressure, it has been difficult to apply it to small air conditioners such as household and automobile ones. Our new cooling technology that can effectively use eco-friendly carbon dioxide natural refrigerants, even at low pressure, has the characteristics of safe and easy maintenance, Therefore, it can be used for small air conditioners. Whereas the conventional cooling technology is cooled using the principle of vaporization and liquefaction of the refrigerant, our technology includes co-fluids capable to absorb a refrigerant together with the refrigerant in the cooler, and utilizes the principle of absorption and desorption of the refrigerant in co-fluids. We have firstly developed the co-fluid candidate materials, which can effectively absorb and desorb a carbon dioxide natural refrigerant and circulate safely and effectively in a cooler. We have also developed the production process of these co-fluids in economic ways. Moreover, we have demonstrated the new air conditioning system using a carbon dioxide natural refrigerant and operating under relatively low pressure by introducing co-fluids in the cooling system. Our technology can reduce the use of global warming gases in use of air conditioner refrigerants, such as hydrofluorocarbons, by utilizing carbon dioxide natural refrigerant with low global warming potential. In addition, we hope our technology can be easily applied to domestic and automobile air conditioning because of lower operating pressure of carbon dioxide refrigeration system with our new technology. Development of greenhouse gases removal system by using combined pump and scrubber technology. Frequent cleaning, operating costs, and excessive energy are used due to efficiency reduction of existing POU scrubber used in the semiconductor process and clogging of piping of a shear pump. In the process of treating fluorine compounds, there are problems of discharging secondary pollutants such as gaseous pollutants and ultrafine particles. We have developed the integrated pump and scrubber greenhouse gas reduction equipment to improve this. Our technology can be installed without the restriction of the internal space of process by integrating the back-end pump of the main equipment in semiconductor processing with the scrubber. And it is possible to save energy by using the POU scrubber, whose structure is different from existing one when decomposing gas. In addition, as it is possible to easily exchange heat between a pump and a scrubber due to differentiated utility structure, the prevention of powder accumulation in pump piping, and the increase of the temperatures of plasma shear improve gas decomposition efficiency to prevent existing heat energy loss and enable efficient operation by reducing frequent cleaning cycle. By rotating a nitrogen tube in the pipe wall inside a plasma reactor, the high heat of the reactor is received and delivered to gas piping at the rear end pump, and then enters the nitrogen injection section of a plasma torch. The nitrogen, whose temperatures have risen, is delivered to gas piping at the rear end pump, and then enters the nitrogen injection section of the plasma torch. This structure increases temperatures before entering a nitrogen torch to assure the safe combustion of gas, and simultaneously wraps the location where nitrogen line applies a double jacket to the rear end pump to solve the existing powder accumulation and help smooth gas treatment efficiency. In addition, heated nitrogen enters the front of the torch to raise the temperatures of the whole fluid, which can keep the internal temperatures of the chamber constant with little energy. By combining CDA or nitrogen injection part utility on the bottom of this equipment, efficient cooling is enabled and secondary nitrogen oxide can be drastically reduced. Integrated pump and scrubber system can efficiently treat harmful gas and simultaneously save energy. The technology can be applied not only to semiconductor process, but also to the treatment of exhaust gas generated in the general industry.